Knovel is an award-winning web-based library of e-references, e-books, and databases for applied scientists and engineers. You can see the 18 subject areas here on the home page. Clicking on any one of the links will take you directly to that subject, such as, say, chemistry and chemical engineering. Each subject area is then broken down into topics for further specificity. I'll show you an example of that by clicking on the General References. Now, Knovel adds value to these ebooks by making them interactive. We'll check out the Chemical Properties Handbook to show you some of these interactive options. Interactive book components include tables, graphs, and equations. I can show you an example of this from the enthalpy of vaporization. We'll look at the enthalpy of vaporization of organic compounds, where all the relevant data is located on a simple interactive table. Interactivity improves engineers' productivity by enhancing searchability and allowing analysis and manipulation of otherwise static data. Here we can see on this interactive table the ability to filter data. You can sort it, and if you'll notice here, we have an equation plotter that also can come in very handy. On the equation plotter, we can see the substance name that we're dealing with, the equation that's used to generate this curve, and as you can just see from here, if I leave my mouse pointer on any spot in the curve, it will show me the corresponding x and y values. Glancing again over at the left-hand side, we can see the x variable, which is temperature, and if we want to, we can change the units. We can also see the range that is available for us, and the significant digits can be changed easily. You can see the y value as well, which is enthalpy of vaporization, and the units for y, kilojoules per mole. Again, we have the option to change the units to pretty wide variety. Now let's say we want to know a value of a specific point and don't want to spend the time mousing over it. We can just simply type in the number, hit enter, and the corresponding y value will show up. So at 500 Kelvin, our y value is 95.26 kilojoules per mole. Users can browse and simultaneously search all titles via a single interface. Basic search, which can be performed in this box, and advanced search, which can be found by clicking here, are fast and optimized for technical users. Now, let me demonstrate how Knovel can help your scientists and engineers to be innovative and more productive. Let's start with a hypothetical situation. A biomedical engineer is designing metal plates that can be used for broken cortical bone. He has to be sure that the metal plates have similar properties to the bone. The plates have to be strong enough to carry normal loads, but not so strong as to induce significant stress shielding effects. Knovel can supply the engineer with the needed information. We will begin by finding the mechanical properties of the cortical bone that we want to match. In the search box on the Knovel Library homepage, we'll enter the phrase cortical bone and mechanical properties. Now, we can type enter or just click search. This query means find any page of text or row of data from an interactive table where the terms cortical bone and mechanical properties are both present and the terms in quotation marks are adjacent to one another. The search page shows the Standard Handbook of Biomedical Engineering and Design has 100% relevancy. We'll click on this link. The table of contents now appears. Only chapters or sections where there are hits from the search query will show by default. The very first section looks promising. 8.4 Mechanical Properties of Cortical Bone. We'll click this link. A new window appears launching the Adobe Reader and displaying an entire section devoted to a discussion of human cortical bone properties. Scanning this section with its detailed discussions, examples, tables, and formulations, the biomedical engineer can document the properties. Now the biomedical engineer wants to look into the possibility of using a magnesium alloy for the bone graft because it has a relatively low modulus of elasticity, or stiffness. We will exploit Knovel's advanced searching capabilities to find a suitable alloy. Again on the home page, we'll click on the advanced search option. Here we have another window that opens up, which contains the advanced searching capabilities. We want to match a keyword with magnesium. In the second field, we want to make sure we only return those with values in our range. Using the drop-down menu for category, I'll select tensile and compressive properties. In the field name drop-down menu, I'll select modulus of elasticity. From the data gathered in our previous search, we want to find alloys with stiffness less than 60 gigapascals. We can select gigapascals here in unit, and our operator, we want it to be less than or equal to. And here we type in 60. Now we can click Search. The search results show that the military handbook contains an interactive table denoting mechanical properties and has 100% relevancy. We'll click on this link. The table of contents once again opens, and we see that we have an interactive table here that has the physical and typical mechanical properties. We'll click on this one. Now another window opens showing the matching entries from the interactive table. This provides the engineer with all the relevant information about the alloy, including grade, UNS number, form, and compressive modulus of elasticity, or E. Notice how Knovel converted the units in our search query to return data that was not in our original units, yet still matched our search criteria. You can verify the latter using a built-in unit converter. As you can see, Knovel was able to provide fast, easy access to accurate information across multiple disciplines for convenient use by a single engineer. I thank you for your time and hope you found this informative.